Good morning, everyone, students. Today we are going to learn our final type of factoring, and it is called the Phoenix method. Now, if you're looking at your note sheet on the next page in the notes, we're not doing the front of it. We're going to go right to the back. The front is one of two ways that I can show you how to do this factoring. Most people choose to just do it the back page way, which is the Phoenix method or slide and divide method. So that's what I want to focus on here. I don't want to, since we're virtual, I don't want to try to show you both and confuse you. I'm going to show you one method. At the end of the day, if we really don't like it, if you like, this one just doesn't work for me, maybe if you come on during office hours, I can show you the other one and you can decide if you'd like that better. The nice thing about the Phoenix method is it follows the same set of directions every time. So as long as we learn this process, we'll be in really good shape. So let's just start with the problem. Example 3, we're on that back of that note sheet, the slide and divide or Phoenix method. And remember what the instructions are. Always read for what are we being asked to do? We're being asked to factor 5x squared plus 8x plus 9. But here's the problem. The GCF isn't 5. Every time we've had a number in front of x squared so far, we just said, oh, GCF, divide everything by 5. That doesn't work here because 18 divided by 5 is a decimal and 9 divided by 5 is a decimal. So the GCF method doesn't work. GCF doesn't work. Now, we should always check to see if there's a GCF, but if the GCF is 1, which it is in this case, the biggest number that goes into 5, 18, and 9 is 1, then we have to do another method, and that's going to be the slide and divide or Phoenix method. And there are 5 steps for us to do here. And so I'm going to walk us through these steps one at a time, and we're going to see how each of them works. So number 1 says slide the lead coefficient under the constant and multiply to rewrite the trinomial. So the reason why some people call it slide and divide is because we're going to slide the 5 over and we're going to multiply 9 times 5. So we're going to rewrite the problem now as x squared plus 18x plus 45. See how I slid the 5 over and multiplied by it. Now this looks like a regular problem. Now that looks like a regular factoring problem. So now I'm ready to do step 2. And step 2 is to factor the new trinomial. So I look at this, and now it looks like a regular problem. It looks like a problem we've been doing all week long, where I need numbers that multiply to 45 and add together to equal 18. Now, 45 is a pretty big number, so maybe you have to start dividing. You do 45 divided by 1, so you get 1 and 45. But that doesn't add up to be 18. 45 divided by 2 is a decimal, so that didn't work. But 45 divided by 3 gave us 3 and 15. So 3 times 15 is 45, and 3 plus 15 is 18. So that told me I factor this as x plus 3, x plus 15. That was step 2. Now, normally we'd be done, but because this is slide and divide, or it's the Phoenix method, I'm not done yet. Step 3 says, now divide. So we slide, we factor, and then we divide by that number 5. So we slid that 5 over, and now we're going to divide both of the numbers in parentheses by 5. And if I can, I'm going to simplify the fraction. So I showed the division, now I'm going to simplify. So now 3/5 doesn't simplify, but 15 divided by 5 does simplify to 3. So do you see how 15 over 5 becomes 3? If you type that in your calculator, you get 15 divided by 5 is 3. Okay, so we're almost done. We did number 4. But here's the problem. I don't like having a fraction in my answer. I don't like having a fraction in my answer. So my final step is any denominator that doesn't cancel, slide it back up in front of the x. This is why some people call it the Phoenix method, is you rise from the ashes, you think you're done, but we're not quite. We have to rise up with the 5. And so it becomes 5x plus 3. So we got rid of that denominator. And then the second factor stayed the same as x plus 3. And that's my final answer. Now, remember that our goal was to factor this problem at the beginning. If I did it correctly, I should be able to FOIL this problem. I should be able to check my answer by FOILing and get the original problem. So 5x times x is 5x squared plus 15x plus 3x plus 9. And yep, that did give us the original problem again, which means that this is the correct answer. So that is good, and we checked it out. So the only thing that's difficult about this method is that there are 5 steps to do. None of the individual steps are hard. We just have to get comfortable doing each of those 5 steps. So we're going to do a couple more problems together, and then I'll have you try a couple on your own. So factor using the Phoenix method. Notice that right now that this 3, 5, and -22, there's not a GCF that goes into all of them. So the GCF method wouldn't work. So what do? I slide the 3 over and I multiply. So I have now not 3x squared, I slid the 3 over, I have x squared minus 5x minus 66. Once I've done that, I'm trying to factor this new problem. So I'm going to try to factor this problem, meaning I need to find numbers that multiply to -66 and add to be -5. Now, one downside of the Phoenix method is that we tend to have some pretty big numbers here to deal with. And so this might be one of those situations where we're getting out our calculator, you have your phone calculator in front of you, and you're just doing -66 divided by 1. Okay, well, that's -66 and 1. But -66 plus 1 is -65. That didn't work. -66 divided by 2 gives me -33 and 2, but -33 plus 2 is -31, so that didn't work. -66 divided by 3, I could have -22 and 3, but -22 plus 3 is -19, so it still hasn't worked. -66 divided by 4. It's a decimal, I don't have to worry about it. How about -66 divided by 5? It's a decimal, don't have to worry about it. -66 divided by 6 gives me -11 and 6, and -11 plus 6 is -5. So that took a lot of work, and it took my calculator to help me out, but I can now factor this blue problem as x minus 11 and x plus 6. But we are not done yet. And that's the tricky part is we can't be so excited like, oh, I did it. I factored it. Yes, we factored the blue, but we factored the blue, not the original problem yet. Remember, it's called slide and divide. We slid the 3 over. Now I divide by the 3 and try to reduce whatever I can. So if you go to your calculator and you try to reduce 11 over 3, it doesn't reduce. So I just write it as x minus 11 thirds. 6 over 3 becomes 2, so that did reduce. Now, looking at this, it's pretty good, but I don't want to ever have a fraction here. And so that means that my final step is to do the Phoenix method, to rise from the ashes, bring that 3 up to make it 3x minus 11. So now there's no longer a denominator, and it looks better, 3x minus 11 and x plus 2. And that answer, if I FOIL it, would give me the original one again. Notice that this green step, if I FOILed, wouldn't give me the original. The purple step wouldn't give me the original. Only this answer at the bottom gives us the original problem if we were to check our answer by FOILing. Let's do another one, another Phoenix method problem here. So for today, I'm going to tell you, hey, use the Phoenix method. Now, by the time we take the test next week, you might have a couple problems where you have to recognize it's the Phoenix method. So how do I know that it's the Phoenix method? Because there's a number in front and it's not the GCF. So step 1 is slide the 2 over and multiply. So I'm turning this into a regular problem now. I'm turning this into a regular problem. Sorry, that should be a 78, not a 38. Turning it into a regular problem by sliding and dividing. So sliding over the 2 and multiplying. So x squared plus 19x plus 78. Now, once I'm there, that is a problem that I know how to factor. Now, sure, it's got big numbers. I need numbers that multiply to 78 and add together to equal 19. And I'll be honest with you, I don't know the numbers that multiply to 78. I know 1 and 78. And I know 2 and 39 because that's the ones we just did. But to any other ones, I'm getting out my calculator and I'm dividing. 78 divided by 3 is 26. 78 divided by 4, decimal. 78 divided by 5, decimal. 78 divided by 6 is 13. So I have 6 and 13, and those two numbers added to equal 19. So it took me a few tries to get the right pair of numbers to multiply to 78 and add to be 19. And I write it as x plus 6, x plus 13. But we are not done yet. It's not the slide method, it's the slide and divide method. And so what I still have to do is divide by the 2. Right now, this clearly is not the factored form of the original problem. If you FOILed it, you wouldn't get 2x squared. So we need to divide by the 2. We slid over the 2. Now we're going to divide by the 2 and try to simplify. So go ahead and see, can I simplify? Well, x plus 6 divided by 2, that's x plus 3. 13 divided by 2 doesn't simplify, so I just write it as 13 halves. And then the last step, the Phoenix method, rise from the ashes, bring that denominator out in front of its x only. So I have x plus 3 was done, and now 2x plus 13. And you can FOIL that answer out and see if it matches up with the original problem. Okay, one more example. It's not on your notes, just another one with a negative and some big numbers. Okay, so this is an extra example that's not on the notes right now. We're still going to follow the same process where I bring the 6 over and I multiply. So I have x squared plus 13x, and then negative 28 times 6 is negative 168. That is a huge number at the end, and that's going to make my life fairly difficult. I'm going to need to find numbers that multiply to negative 168 and add together to equal 13. So I'm just starting, and I'm pretty sure it's not negative 168 and 1, okay, because that doesn't work. But I'm doing negative 168 divided by 2, and I got negative 84 and 2. That doesn't add up, okay? Negative 168 divided by 3. Okay, so negative 56 and 3, that works. Oh, but negative 56 plus 3 is negative 53, not 13. So now I'm looking at this, I'm saying, okay, I'm probably going to need the bigger number to be a positive. So I'm going to do negative 168 divided by 4, and I got 42. I'm going to try 42 and negative 4. 42 plus negative 4 is 38. So I'm positive, which is good, but still pretty far away. Negative 168 divided by 5, decimal. Negative 168 divided by 6 is negative 28. So I'm going to try 28 and negative 6. Well, 28 plus negative 6 gave me only 22. I'm getting closer, but still not there. Negative 168 divided by 7. Okay, so 24 and negative 7. But that gave me 17. Starting to realize how much work this is, and that's okay. It's going to take me a few steps to find the right pair of numbers, and I'm not giving up. Going back, negative 168 divided by 8. So I'm going to try 21 and negative 8. And 21 plus negative 8 is 13. So I persevered. I found two numbers that multiply to the constant and add to the coefficient 13. And so I write I factor the blue as x plus 21 and x minus 8. Now, I've done that. Now it's time to divide. It's slide and divide. So I divide by the 6. Now, this one might be really tough if you are not great at simplifying fractions. I don't know what calculator you have at home, but I really wanted to show us one like this, where 21 divided by 6, if I divided it, would give me a decimal 3.5, but it reduces as a fraction. And what it reduces to is 7 over 2, because 3 goes into both 21 and 6. 3 goes into 21 7 times and 6 2 times. Now, if we were at school with the yellow calculator, the calculator could do that reduction for us. So thinking about that on the test, I'm probably not going to give you one quite like this, but I wanted to expose you to it. Same thing over here, x minus 8 over 6, that reduces. 2 goes into both of those. 2 goes into 8 4 times and 6 3 times, so it's x minus 4/3. So I did try to reduce them, so, and in fact, they did reduce, but they still were both fractions. So that means on both of them, I have to do a little phoenix rise from the ashes, like this. And that gives me my final answer. So it's possible that both of the x's could have a number in front of them. Now, what I want you to try to do is to factor each trinomial using the Phoenix method. And so what I want you to do is kind of on this first one, try the first step and see if it matches up with what I do. So go ahead and try it right now. So hopefully you multiplied by 5 and you had x squared plus 6x plus 5. Now what I want you to do is find the numbers that multiply to 5 and add together to equal 6. And I want you to go ahead and type those numbers in the box for me. Okay, so hopefully you did 5 and 1, not 3 and 2. 3 times 2 is 6, and we need numbers that multiply to 5. So 5 and 1, because 5 plus 1 is 6. And so we'd have x plus 5, x plus 1. Okay, well, you're not done yet. Now see if you can do the next step for me. So go ahead and try that next step. Right slide and divide both of them by 5. And then say, does anything reduce? Yeah, so x plus 1. And then over here, it didn't reduce, so we're left at 1/5. And so then do the final answer for me. And what I want you to do is type your final answer into the box. So if we had x plus 1 and then 5x plus 1, we brought that 5 in front. Okay, I want you to try this problem entirely on your own. Now, this is a longer problem because it's got a bigger number at the end. Probably use your calculator, but go ahead and do this entire problem. And then when you're done, type your answer, the factored form of your answer into the box for me, and then I'll share my answer and you can make sure that you agree. Okay, so I multiplied the 3 over. So if you're checking your work, is this what you had for your first step? And then we were looking for numbers that multiplied to 105 and added together to equal 26. The correct pair of numbers there was 21 and 5. 21 times 5 is 105. 21 plus 5 was 26. So I factored that as x plus 21, x plus 5. Looking at your paper, is that what you had? If not, perhaps you found the wrong pair of numbers here. Now, hopefully you didn't stop here because we're not done yet. This does not have a coefficient in front. I need to divide the 3 again. So divide by 3 and reduce x plus 7. And then this one did not reduce. So the final idea was to bring that 3 in front to make it 3x plus 5, get rid of the denominator, and then leave the x plus 7. Now, hopefully, this is what you had for your answer. And if not, I'm not going to mark you wrong for this one. But it lets me kind of get an idea of how we're doing on problems like these. So what's next? There's no homework on Phoenix method yet. Okay. What you have to do to submit for today's work is the factoring recap worksheet from earlier. And then remember that there's a mandatory live session tomorrow. We're going to kind of finish up the notes by doing a few more Phoenix method problems. And then we're going to play review bingo. I'm going to start at 7:45 promptly. So right when attendance period ends, I am going to start the lesson. And you are expected to stay on and work with me through those notes and then play review bingo. I'm guessing we'll be done by 8:30. Can't imagine that we go much beyond that. And then for tomorrow, the only thing you'd have would be, in addition to that, is test review number 1 as homework. Thanks for watching. Have a great day.